Hello Ajay. We will start the meeting in 10 minutes. Okay. We will wait if anyone joins, then we will start. Okay. My name is Ganesh Chandra Bhandari and I am a NPTEL PMRFTA for Municipal Solid Waste Management 2024 taught by Professor Ajay Kalam Daf. So we will start our live session week 9. So first we will go with some revision of previous week lectures. Okay. So until yet, we have taught about different types of waste generation. Then we learned about the primary collection and primary collection setups like haul trucks or stationary systems. Then waste handling and storage systems, followed by the secondary collection procedures. Then transfer and transportation of that municipal solid waste, and during before transfer and transportation, processing and transformation. And in processing and transformation, we learned about the composting processes and anaerobic digestion process to convert the municipal solid waste in to the compost material, which can be used as a fertilizer in agriculture, or we can produce the CH4 or biogas fuels with the help of the anaerobic digestion of this municipal solid waste. After the transfer, transport, and processing and transformation, the remaining waste has to be disposed of. Okay, so that procedure is known as the disposal of this municipal solid waste management. So where we are going to dispose this waste, obviously we are going to dispose it off in a landfill. Okay, so because it after the processing steps, it does not contain any useful material inside these wastes. So we will go for the landfilling of this solid municipal waste. Okay, so there are some factors. So for landfill, we need a site. Okay, and for site selection, we have to consider some different factors. Okay, before deciding the site for landfilling of these municipal solid waste. So first, we will talk about the history of solid waste management in India. In earlier days, the solid waste was dumped in unoccupied land stretches, or we were burning the waste in the open, so that it can be destroyed off. But with the problem with the burning of these waste are it will produce some greenhouse gases, and it will uh, cause some air pollution during the burning process. In 1994, large scale flood due to heavy rain and clogged sewer resulted in a plague epidemic in Surat. So one due to these hazardous health conditions, one of the philanthropist Almitra Patel has filed a PIL in Supreme Court, and that resulted in the formation of a Burman committee to improve the solid waste management in the country. Then Burman committee submitted the report to Ministry of Environment and Forest that introduced the Special Act of Municipal Solid Waste Management, which is known as Rules 2000. Then after that, there comes a rule of SWM 2016, which is uh, in practice nowadays. Okay, so there are many problems associated with the open dumping of these solid waste management. So in open dumping, it is a disposal of solid waste in a manner that does not protect the environment and are exposed to element, vectors, scavengers. They are also susceptible to burning. So instead of open dumping, we need to go for the landfilling process of these municipal solid waste in a proper manner, so we can uh, inhibit inhibit the external vectors, scavengers, and different types of health hazards created due to the landfilling of created due to the open dumping of this municipal solid waste. So open dumping poses huge environmental and health concerns. The waste dump could catch fire and pollute the atmosphere, and it can result in the formation of methane gas, which is uh, very susceptible to the fires. And open dump sites are breeding grounds for disease carrying vectors, it attracts mosquitoes, rats, and fleas, which can result in the which can result in different types of health hazards like plague or dengue or something like that. Then, since the waste in open dump site are not properly covered, they are exposed to natural elements such as wind and rain. And if the rain water will come into the contact with this municipal solid waste, so it will leach out the hazardous elements present in the municipal solid waste, and with the help after the leaching of these hazardous elements inside the water, that water will go inside in the groundwater, and it will contaminate the groundwater, which will result in major health problems. Then open dumping decreases the quality of life to nearby resident and the local community. So coming to the landfill, so landfill are the physical facilities which are used for the proper disposal of residual solid waste in the surface of the earth by considering different types of factors which inhibit the health hazards during the disposal of this municipal solid waste. So landfill includes monitoring of the incoming waste stream, placement and compaction of waste so that it can be in a smaller area. We can landfill larger amount of municipal solid waste, and installation of landfill environmental monitoring and control facilities. So there are two types of landfills. One is sanitary landfill, which is an engineered facility for the disposal of municipal solid waste, and another one is secured landfill. That is for the that secured landfill is used for the disposal of the hazardous waste. So coming to the design life of these landfills, life of a sanitary landfill comprises of an active period and a closure and post disclosure period. Then active period of these sanitary landfills can vary from around 20 to 25 years depending on the availability of the land area. And then closure and post closure period for which a sanitary landfill will be monitored and maintained will be around 15 years and more after the active period is completed. So after the active period of 25 years, we have to still we have to monitor that landfill site for at least 15 years, because we have landfill that waste, and after the landfilling of waste, what will happen, there will be some anaerobic digestion, because there will be no proper air circulation inside that landfill area. So due to that anaerobic digestion process, what will happen, that can convert that municipal solid waste into the methane gas, or it can react with the rainwater, and due to the reaction of that rainwater with the landfill waste, it will leach out the hazardous elements inside that water, and it can contaminate the groundwater. So after the landfilling time period is over, we have to monitor that landfill site for at least 15 years. Then only we can uh, we can close that dumping site. Okay, so status of municipal solid waste management in India: house to house collection of waste, it is happening in around 18 states out of 29. Then segregation of waste at source, it is only happening in 5 states at all from 29 states. Then number of unsanitary landfill sites identified are 1285, and number of sanitary landfill sites which are constructed in a proper manner, that is only 95. So if we are going to compare them both, then we only have around less than 10% of landfill sites which are properly constructed with keeping in mind the different factors affecting these landfill sites, uh, compared to the unsanitary landfill sites which has been identified as in a major amount around 1285. Then types of municipal solid waste which can be accepted at landfill sites are, there are different waste categories which are suitable for sanitary landfills, like non biodegradable and inert waste by nature or through pre-treatment. Then commingled waste, that is basically mixed waste not found suitable for waste processing. Then pre-processing and post-processing rejects from waste processing sites. non-hazardous waste not being processed or recycled. So these are the different types of waste which can be accepted at the landfill site. Like if we talk about the non-biodegradable waste, we cannot convert them into the anaerobic. We cannot convert them into biofuels with the help of anaerobic digestion, or we cannot convert them in the fertilizer material with the help of the composting processes. So, or inert waste will be there, which cannot be converted into any useful products. So that will go into the landfill sites. Then there will be some pre-processing and post-processing steps. Waste rejects, like in anaerobic digestion, we were creating the reject material uh, after the completion of the anaerobic digestion process. So that post processing reject will go into the landfill sites, because that is generally treated as a inert material. Then non hazardous waste, which is not being processed, or we were not able to recycle that non hazardous waste. Then there are some definition of there are some different terms which are generally used during the formation of a landfill sites, like cell, that is volume of materials placed in a landfill during one operating period, usually 1 day. It includes the waste deposited and the daily cover material surrounding it. So daily we have to fill some material. Okay, so we are going to create a cell, and then after creating that cell, so we will calculate the area required for the daily waste disposal. Okay, because we know the capacity what is going what will be going to come during the municipal solid waste handling. Okay, so we know the area required for the daily waste disposal. So we are going to create a cell for the daily waste disposal, and after that cell creation, we will cover that disposal waste with some linings. Okay, so that it cannot come into the contact with rainwater or something else which is going to leach the material, or which is going to create the odor formation during the landfilling. Okay, then daily cover, it consists of 6 to 12 in of native or alternative material such as compost that are applied to the working phases of the landfill at the end of each operating period. It controls the blowing of the waste material, entry of water, and prevent disease vectors from entering the landfills. So after filling the daily disposal, okay, we will cover it with the help of some organic material so that it cannot come into the contact with the vectors or water every day. Then coming to the third term, that is known as lift. Complete layer of cells over the active area of landfill is known as the lift. So that lift height is usually up to can be around 6 feet, or like 7 feet, something like that. Then another term is bench or terrace. Bench or terrace term is used where height of landfill exceeds 50 to 75 feet. It maintains slope stability of the landfill, placement of surface water drainage channel, and for landfill gas recovery piping. So, as we have already discussed, during the landfilling, there will be no access to the air for the waste which has been disposed in that landfill site. So due to the uh, because this waste is not having any uh, proper contact with the air, so it will, so some, if there is some organic amount still present inside that waste, okay, that will go into the anaerobic digestion process, and that will convert that municipal solid waste into the gases, different types of gases like CH4 or ammonia. So those gases has to be drained out from that landfill site in a proper manner so that we can reuse those gases, or and we can prevent the odor formation, or we can prevent the major mishap in that landfill site, because these gases are susceptible to catch the fire, because it contains a major amount of CH4, and it can easily catch the fire. during the summer. Okay, so that has to be kept in consideration before designing any landfill sites. Then final lifts it's include the cover layer, final cover layer applied to entire landfill surface after entire landfilling operations are completed. So that final cover layer is like so we are going to fill any landfill sites for at least 10 to 15 years, and after that completion of that 10 to 15 years, we are going to cover that landfill site with the help of a final cover layer. So that will be applied to the entire landfill surface after entering entire landfilling operations are completed to prevent the interaction of that municipal solid waste with rainwater or external vectors or some other or air, something like these things. Then leachate, that is known as a liquid collected at the bottom of the landfill. So we have to provide the proper system for the collection of the leachate material, which is coming after the reaction of these municipal solid waste with the rainwater. Then landfill gas, it is a mixture of gas, mainly mixture of gases, mainly CH4 and CO2, which is formed as a result of degradation of biodegradable organics present in the waste material. Uh, Hello, Vasanta, you want to say something? And then coming to landfill liners, these materials used to line the bottom area and below uh, grade sites of a landfill. They usually consist of a layer of compacted clay and or geomembrane material designed to prevent migration of leachate and landfill gases into the groundwater. Okay, because if they are going to transfer it into the groundwater, they are going to contaminate the groundwater and it will create major health hazards. Okay, then there are different types of landfilling methods. There are three different types of landfilling methods. First one is excavated cell or trench method, then area, and third one is canyon or depression method. So in excavated or trench method, uh, this type of method is generally used where groundwater table is not near the surface. Okay, then trenches are dug and lined with synthetic membrane liners like geomembranes and low permeable clay or a combination of both. So the leachate water is not going to uh, not going to get in contact with the uh, groundwater. Okay, so that trench has to be covered with the help of the geomembrane or low permeable clay, which will prevent the water absorption in the soil. The solid waste are placed in the trenches and the soil excavated from site is used for daily and final cover. These trenches are can be around 200 to 1000 feet long and 3 to 10 feet deep and 15 to 50 feet wide. Then another method is area method. This type of method is used when terrain is unsuitable for excavation, such as when the groundwater table is high. Okay, if we cannot dig up to 15 or 20 feet, if groundwater can be found at around 30 feet or 40 feet in some areas, so we cannot dig a trench. Okay, then in that case, we have to go with the area method. So in area method, the cover materials are hauled from different locations. Site preparation includes installation of liner and leachate control systems. Then third one is canyon or depression method. So canyons, ravines, dry borrow pits, and quarries can be used as landfill sites, and compacted solid waste are placed in canyon or depressions. In this type of method, you don't have to dig. Okay, you will fill that waste material into a naturally available canyon or ravines or dry borrow pits. Okay, So compacted solid waste are placed in these canyon and depression. Then cover materials can either be excavated from canyon walls or hauled in from a different location. Then there are some factors which needs to be considered while deciding a landfill site. So haul distance has to be close to generation site. Then location restrictions are 20. It has to be at least 20 kilometers away from airport, 200 meters away from highways, and 5 meters from habitation, and 300 meters from public park, 500 meters from water supply well. So it cannot contaminate the groundwater, and 200 meters from pond and 100 meters from rivers. Then available land area, that has to be at least for minimum for 20 to 25 years, because in landfill site will take at least 20 to 25 years to proper fill up of the municipal solid waste material into that landfill site. And after that also you have to uh, monitor that landfill site for at least 10 to 15 years more. Then site access, it should have proper access to the road, so that transportation can be easily done. Then soil condition and topography. The soil, if used as cover material, should have low porosity, or and the topography decides the extent of work required to make the site usable. Then there has to be takes into consideration some climatology conditions, then surface water hydrology to establish the existing natural drainage or runoff, geologic and hydrologic conditions to ensure that the leachate or landfill gas will not impair quality of local groundwater or subsurface of bedrock aquifers. Then there has to be taken into consideration some local environmental conditions, then potential ultimate uses for the complete site. Because after landfilling also, if when 25 to 30 years are over, then we cannot leave that site as it is. Okay, so we have to consider the potential ultimate uses of that complete site after the landfilling process is over. Hello, Vasanta, can you switch off your mic? Then site during site selection, there should be location criteria, search area, development of a list of potential sites, data collection for potential sites, field visit for local verification and identification of potential sites, selection of best ranked sites. Then we will go for preliminary environmental impact investigation. Then only the final site selection will be finalized for the landfilling site. Then these things we have already discussed. Then search area, data collection for potential sites, field visits. Okay. Then
Sir, can you please zoom in a little bit?
uh,
Sir, can you please zoom in a little bit, the PPT?
okay. It is okay now.
Yes, sir, it's fine.
Okay. So we have talked about the different types of landfill sites and what factors we need to take into consideration during while deciding a proper landfill site. Okay, so after deciding the proper landfill sites, we have to also install the leachate collection and gas treatment systems in that landfill sites for the proper disposal of the leachate produced during the landfilling and the gases produced during the landfilling of the municipal solid waste. So there are two most common problems which are associated with the landfill sites. One is landfill gas. Okay, so there will be some organic material such as wet waste are usually compacted when they are put into the landfills, and due to the improper oxygen content, okay, that organic material will go into the anaerobic digestion process. Okay, and that anaerobic digestion process will result in the production of CO2 and CH4 gases during the landfill. Okay, so those CH4 and CO2 gases has to be properly captured in that landfill site. Otherwise, these these are the major part of the greenhouse gases, and that will create the major greenhouse effect. So that will create some major air pollution. Okay, so we have to properly consider, properly create a system for the capture of these landfill gases. So there are two major advantages after the catching of these major gases. One, we are inhibiting the air pollution or greenhouse effect. Then second one is the major content of these gases includes around 60 to 70% of methane gas. Okay, so this methane gas can be reused as a biofuel material for different purposes. Okay, so after the capture of these this gas, we can provide some economy also. Okay, after selling these gases. And second one is, so there will be some complex reaction which will occur during this the landfilling of these sites like hydrolysis. These types of reaction we have already discussed during the anaerobic digestion process. So these organic materials first will go into hydrolysis process, followed by the fermentation, and then acetate formation. And after the acetate formation, that acetate is again going to decompose into the CH4 and CO2 gas formation. Okay, so so the same reactions which were occurring during the anaerobic digestion process will occur in these landfill sites. Then this also we have discussed during the anaerobic digestion process. So typical phases of landfill gas and leachate are, so as we can see, as we are going to increase the volume of these things. So there is first phase, then second phase, third phase, and volume is going to increase. So in third phase, the stabilization gas production will be on maximum. Okay, so it will be at around okay. No, that is not like that. So there is a typical phase of landfill gas and leachate. So we have uh, implemented the stabilization gas production with respect to the incremental, with respect to the gas composition and percent by volume and chemical oxygen demand. So what is chemical oxygen demand? Okay, that the chemical oxygen demand is defined as the uh, optimum amount of oxygen which is required for the proper conversion of the organic waste into the CO2 gas. Okay, so if we are not providing the proper amount of the oxygen to the system, okay, so what will happen? It will go into the anaerobic digestion process, or we can say anaerobic decomposition process, and that will result into the formation of CH4 and CO or S2 type gases. Okay, so obviously in during the landfilling side, we will not be able to provide the proper amount of oxygen to the municipal solid waste. Okay, so due to that improper oxygen passes, the anaerobic digestion process will happen. Okay, and that will result into the production of the CH4 and CO2 gases, which will generally increase in the fourth phase of the this landfill system. And the CH4 gas production can go up to a maximum of around 400 meter cube with a at gas composition of around 400 meter cube. A maximum CH4 content of 45 to 50% can be achieved. Okay, then there are different factors which influence leachate generation process during these landfills. So leachate varies widely depending on the age of the landfill, type of waste, what was the composition of that waste material, if that waste contains some non-biodegradable material or it contains some heavy metals. So heavy metals are easily leachable, okay, with the rainwater, okay. So that composition will play a major role in the leachate composition. Then what are the environmental conditions? Okay, so environmental conditions like what the temperature, what maximum temperature can go up to that landfill sites. If we are talking about Delhi, so a maximum temperature of landfill surroundings can go up to around 49 or 50 degrees, and in the landfill it will be at around 80 or 90 degrees Celsius inside the landfill site. Okay, and if we talk about a landfill site in Jammu and Kashmir, so maximum temperature can go up to only 30 or 40 degrees, 30 degrees Celsius in surroundings, and in the inside the landfill it can go up to around 50 or 60 degrees Celsius. So the temperature will play a major role during the leachate operations. Okay, so we know if we are going to increase the temperature, okay, so the reaction kinetics will happen faster, okay, and the metal content which are going to be leached inside that water, it will become more, okay. So uh, that will vary the quality of the leachate which is going to produce during these landfill sites. Then factors which influence the generation of leachates are infiltration of groundwater, infiltration of leachate into the ground, a potential pollution of the groundwater, then rainfall. Okay, if rainfall is on higher side, then the leachate produce will be on the higher side. Or if we talk about Rajasthan, so landfill, so rainfall will be on the lower side, so the leachate generation will be on the lower side. Then water from the deposited waste. So what was the moisture content of the deposited waste? If it was higher, so the leachate generation will be on higher side, or if it was lower, so the leachate generation will be on the lower side. So schematic, this is a schematic scheme of how leachate is generated. So there will be, it is there we can see a rainfall, or we can say precipitation. So this rainfall is going to infiltrate into the landfill sites. Then there will be percolation, then moisture content of waste, and it will create the leachate. And some leachate can escape to the environment, like we can say into the land, into the soil content which is on the bottom side of the landfill, or some will collected on the some will collected as a surface runoff, and some will go as a leachate. Okay, so there are different factors that will influence the leachate quality, like refuse composition. What is the quality, or quality variation is higher for participable waste that for non-putrescible waste. Then elapsed time, leachate quality varies with time. In general, overall quality of leachate generated in 1 year will be less strong than subsequent years. Then ambient temperature, what is the ambient temperature that will affect both bacterial growth and chemical reactions during the landfilling. Then what is the available moisture, because water plays a significant role in biodegradation and subsequent leaching of chemicals out of a waste. Then precipitation, the amount of rain falling on landfill influences the leachate quality significantly. Then groundwater intrusion, sometimes landfills based construction below the groundwater table may increase the quantity of the leachate. Then moisture content of waste, leachate quality will increase because of on-solve weight. The waste release more water when squeezed. Then
Sir,
estimation, yes.
sir, what is the meaning of refuse composition? First point, leachate quality, like putrescible waste and non-putrescible waste. I didn't understand.
Uh, it's like we have already talked about the deformation processes of the solid waste. Okay, so municipal solid waste contains can different categories. Like it can contain inert waste from the construction industry. It can contain the dry leaves. It can contain some inert waste like dirt sweepings from the streets, or it can contain the kitchen waste. Okay, so what types of different content which is coming into in that refuse composition. Okay, if we are going for the composting process, or if we are going for the anaerobic digestion process before going for the landfillings, so that will decide that refuse composition. So putrescible waste are like, we can say, if it is going to contain the inert waste material. Okay, okay, so that inert waste material or hazardous waste will contain some, uh, we can say, heavy metal contains in that waste. Okay, so those heavy metals are going to be easily leached out during the rainfall. Okay, and that will vary your leachate quality, because that leachate has to be properly treated before disposing that leachate off into the groundwater system or into some river or something like that. Okay, so you have to treat that leachate material. Otherwise, if the organic content of that refuse composition is on the higher side, okay, so that will create the lower amount of the leachate, because organic content will first go into the anaerobic digestion or decomposition process. Like, it will convert into the compost material. It will create the more amount of gases during the landfill. Okay, during the reactions which is going to happen inside that landfill area, it will create more amount of the gaseous materials, not the leachate material. Okay, so those are two categories: petrochemical waste and non-petrochemical waste. Non-petrochemical will contain more amount of the organic material, convert which will create more amount of the gaseous material, while the petrochemical, that will create the more amount of the leachate material. Okay, so understood.
Yes, sir.
Okay, then we can estimate the leachate quantity which is going to produce during the prop, uh, proper whole tenure of the landfill site, or we can, uh, so pre-closure generation rate will be LV equal to P plus S minus E minus AW. So LV stands for pre-closure leachate volume. Then S stands for volume of pore squeezed liquid. So that can be determined with the help of the moisture content of the material which has been landfilled. Okay. Then volume of precipitation, that can be calculated based on the rainfall. Then volume lost through evaporation process, that can be calculated with the help of the ambient temperature outside the landfill site. If the ambient temperature is on the higher side, like 50 degrees Celsius or 49 degrees Celsius, so the evaporation will be more. Okay, or if it is on the lower side, like 30 degree or 25 degrees Celsius, so evaporation will be on the lesser side. Then AW is volume lost through absorption in waste, or we can say absorption in the soil. Okay, so we can estimate the leachate quantity depending on these different factors, and we have to calculate that leachate quantity. Why it is required? Because we have to close that landfill site at around, we are going to landfill for around 15 to 20 years. Then we have to monitor the leachate quality for at least 15 to 20 years. Okay, so with the monitoring of that leachate quality or the gases generation during that tenure, we will be able to decide if we have to finally close that landfill site or not. Okay, on the basis of the leachate quality or quantity, we can decide the time period of the closure of that landfill site. Then post closure generation, after the construction of the final cover, only the rainwater that can infiltrate into the waste and generate leachate. Five approaches are available to predict the long-term leachate generation rate. So after the post-closure, okay, so pre-closure, like we have talked about pre-closure time period of around 15 years, then post-closure time period of around 10 to 15 years. So after the pre-closure tenure is over, landfill 15 years of the landfilling is over. Okay, so we will provide a proper membrane, or we can say a proper cover on that landfill site. Okay, so that after that proper covering of that landfill site, the rainwater will not be only a few amount of rainwater will be able to infiltrate inside the landfill site to generate the leachate. Okay, most of the rainwater will uh, come fall off from that geomembrane only. Okay, because we are providing that geomembrane on the landfill side, over the landfill side, to prevent the moisture absorption after the pre-closure period of landfilling. So there are 5 approaches which are available to predict the long-term leachate generation rate. That is water balance method, computer modeling in conjunction with water balance method, empirical equations, mathematical modeling, and direct infiltration measurements. Then coming to water balance methods, a empirical formula is LB equal to P minus ET minus R minus delta S. So LB is post-closure leachate volume, P is volume of precipitation, which is decided with the help of the rainfall. Then ET is volume lost through evapotranspiration. Then R is volume of surface runoff. Delta S is volume of soil and waste moisture storage. So water balance method is applicable only for the landfill sites which are which has high permeable layer of soil as a final cover, or low permeable layer of soil. Then typical leachate characteristic of municipal solid waste are around that will the pH value of that typical leachate will vary from 3.7 to 8.9, and electrical conductivity will be in a wider range around 480 to 720,000 microsiemen per centimeter. Then biological oxygen demand will be around one will vary from 0 to 1,95,000. Then chemical oxygen demand will vary from 66 to 99,000. Iron content will vary from 0 to 400 ppm. Potassium content 0 to 3 to 00 ppm, and magnesium content will be around 4 to 780 ppm. Then we can see a leachate is flowing through a pipe in a sanitary landfill site. So we have created a pond for the leachate collection. Then this leachate will be treated in this pond before going for the proper disposal of this leachate content. So this is continuation from this typical leachate characteristic. The ammonia or nitrogen generation will be around 0 to 1200 ppm, sulfate 0 to 18. So these are different numbers which can vary according to the municipal waste characteristics. What type of municipal solid waste has landfill, the characteristic of the leachate will depend on that municipal solid waste quality. Then coming to leachate collection systems. So in a typical design of the leachate collection system, that is going to be a combination of main drain, side drain, perimeter drain, drain and protective layer, then leachate wells, typically with pumps. So there are different leachate problems that leachate can clog up with silt or mud and growth of microorganisms in the pipes, or chemical reactions leading to precipitation of minerals in the pipes. Okay, so we have talked about the formation of the magnesium, iron and potassium content. So what will happen? These metals can precipitate in the pipes which are required for the leachate flow from the landfill site. So that will create the clogging up of the material inside in these pipes. The pipes become weakened by chemical attacks like acids or solvents or oxidizing agents. Then role of LCN. So there are different roles of these LCS components. First one is barrier layer, a very low permeability synthetic or natural soil linear to restrict and control the rate of vertical downward flow of liquid. So this layer will be provided on the top of the we can say top of the landfill site. That is very low permeability synthetic or natural soil liner, which will restrict the control and rate of vertical downward flow of liquids. Then drainage layer, a high permeability gravel drainage layer to laterally drain the liquid to the collector drain pipes at least 30 centimeter thick with a minimum K of 10 to the power minus 3 centimeter per second. Then slope to encourage lateral migration, minimum 2% bottom final slope after long-term settling. Then French drains and trials which will maximize the amount of leachage diverted to and collected by the tile drains, subangular gravels. So these are the design process of a landfill site. In that way, we have to properly design a landfill site for a proper leachate to create a proper leachate collection system. So this is a typical leachate collection system. Then there are some figures of schematic of various leachate discharge pathways. Then coming to leachate collection systems with graded terrace, leachate seep remediations. These are some figures of different types of leachate collection system. Then components of leachate collection systems, which we have discussed above. So this is refuse, a soil layer, then a French drain, then tile drain, then this is drainage layer, then coming to then there will be a low permeable liner and undisturbed native material. So these are the schematic diagrams of some clean out systems for leachate material. Then there has to be for every landfill sites we have to create a leachate ponds, or we can say lagoons, which will be required for the collection of the leachate generated in that landfill site for the proper disposal, or we can say proper uh, so we can provide some proper disposal, we can provide some proper treatment to that leachates before the final disposal of these leachate liquids. So lined leachate ponds or lagoons are commonly used at landfill sites. The double liner is used at the bottom of the liner as a barrier layer with a leak detector might be employed. Then aerators are provided as initial leachate treatment to reduce odor issues. We have to provide because there will be some we have already discussed, there will be some amount of nitrogen and sulfur and some ammonia gases into some ammonia in these leachate liquids, and for the proper decomposition of these acids or base contents, we need we have to provide the proper oxygen content, which we termed as chemical oxygen demand for the proper reaction to happen there. Okay, so if we are going to provide the proper amount of oxygen into these leachates, okay, what will happen? The ammonia will be going to convert it into the NO2 gases, and sulfur is going to convert it into the sulfur gas, and methane content, if some organic content is there, that is properly going to convert into the CO2 gases. Okay, so proper aeration has to be provided, and it will also help in the reducing odor issues which will be created due to the improper decomposition of this leachate liquid if we are not going to provide the proper oxygen content to that liquid. So we have to provide some leachate storage tanks or structural basins with primary construction materials including steel, fiberglass or concrete. So the material of these construction material of these leachate tanks has to be inert, because the pH range of the leachate liquid will vary from 3.5 to 8.5. So it has to be inert material so that it cannot get react with the leachate solution. Storage tanks are remain open to the atmosphere and often include manifold diffuses of air addition for the proper decomposition of the leachate liquid. Then coming to leachate control, the best way to control leachate in landfills are strict stormwater and runoff water, proper segregation of wet and dry waste, because if we are not going to landfill any wet waste into the landfill sites, okay, so there will be the moisture amount of that landfill sites will be on the lower side, resulting in the lower leachate formations. So that can be done with the proper segregation of wet and dry waste, so that wet waste can go for anaerobic digestion or composting processes, or dry waste or inert waste can go for the landfilling of the municipal solid waste. And aerobic landfill technology, or we can provide aerobic landfill technology, like we can provide the proper oxygen aeration system in the landfill sites. So the proper due to that proper aeration, what will happen, there will be proper decomposition of the materials which is inside that landfill site, for the so that gaseous generation will be on the higher side, gaseous generation will be on the higher side, and those gases can be collected as a fuel material. To restrict the storm and runoff water, use proper liner systems. Sorting into waste categories like wet, and dry waste leads to reduced leachate generation from the landfills. Then design of landfill liners. There are different designs of landfill liners which are used for the leachate control during the landfill sites. First is geotextile, which is a thin synthetic material which is used to minimize the intermixing of the soil and sand or gravel layers with the municipal solid waste. Then geonet together with the geotextile, the drainage layer to convey leachate to leachate collection system. So that layer will inhibit the absorption of the leachate into the groundwater or soil. Okay. Then coming to next one, geomembrane. That is a synthetic material which serves as an impervious barrier to the movement of the leachate and landfill gas. So this geomembrane will inhibit the absorption of the leachate or landfill gases into the soil, or if we are going to if we want to create a proper we can say, after one batch we will provide a geomembrane. Okay, then we will fill up the waste up to some height like 3 or 4 meter, then again we will provide a geomembrane, and between those batch areas, okay, between those plots of 2 meters or 1 meter or 2 meter height, we are going to provide some movement system for the leachate and landfill gases. So that will create a separation between the uh, landfill site itself. Okay. Then clay liners which may crack due to decision, and it needs to be ensured that clay does not dry out as it is being placed. Then leachate treatment, before going for the disposal of these leachate, we have to go for some leachate treatment process. So there is some physiochemical processes like reverse osmosis process. In contrast to biological treatment, it is a separation process with two streams, one low polluted permeate stream and one high polluted concentrate stream. So we have to go for different types of processes like reverse osmosis. Then there is requirement of some biological treatments, like we will provide some oxygen content into that material for fulfilling the biological oxygen demand, or we can say chemical oxygen demand of that leachate system. Then in many cases the separation of ammonium is poor, which could be improved by chemical addition to adjust pH, or by a two-step reverse osmosis process. Then flocculation or precipitation process, because these leachates will contain some amount of, we can say, some amount of slimes into that leach material. Okay, which will be having very lower size, which cannot be segregated with the help of some filtration or something like that. because the size of those components is on the very much lower side. So we will go with some flocculation process. So what the flocculation reagent will do, it will create the cluster of the particles inside that material, inside that leachate. And after creating the cluster of those particles, we can go with some precipitation process, or we can go with uh, some filtration process to remove those particles from that leachate system. Then evaporation and drying. These techniques are a separation in a clean water stream and a solid phase, which includes all pollution material. Normally the solids are pulpy and the condensate vapors contain volatile components. The predominant components in effluent of evaporation plants are volatiles, sometimes chlorinated organics and ammoniums with the necessity of additional treatment itself. Then we can go with aerobic biological treatment process for leachate pre-treatment. So a simple leachate treatment system in which we are going to provide the proper oxygen content, or proper with the proper oxygen content, and with the help of some bacteria which can develop per unit time as the number of species that are transported out of the lagoon with the effluent. So those, with the help of those bacteria and with the help of the oxygen, we can we can properly decompose the organic content present inside that leachate material, and after the decomposition of that organic content, that water can be disposed of in the rivers, or we can dispose it off in the groundwater system. Then there is some activated sludge systems also. The detention time in activated sludge plants are shorter than in aerated lagoons, because the sludge content uh, can be controlled to a certain degree and is several times higher than aerated lagoons. Detention time is reduced by installing a settling tank behind the aeration tank and recirculating the sludge back into the activated sludge tank with a certain amount of sludge removed out of the system. So these types of sludge systems can be we can use we generally use these types of sludge systems in for the disposal of sanitary waste. Okay. um, or we can say for the conversion of sanitary waste into ammonia gases. Okay. So these types of activated sludge systems are used. Then rotating biological contractors and trickling filters. So in these types of systems also, we are providing the proper aeration system for the decomposition of the leachate material. Then leachate treatment, anaerobic biological treatment can be done with the help of anaerobic biological treatment. We can convert that leachate system into the fuel gases. Okay. Then there are some integrated treatment systems. So there are some aspects for leachate treatment plants, like limited concentrations, low demand of resources, low demand of energy, low generation of residues or especially hazardous waste. Then they have low environmental impact and economical. They are economically efficient operations. Then there are some advanced leachate treatment technologies like moving bed biofin reactors, then membrane bioreactors. So these have these types of reactors have some advantages and disadvantages. But in that case, the main disadvantage with these types of reactors is high capital cost. Okay, you have to go for a because for plant making you have to uh, provide some proper machinery systems so that the reactors can work. Then current practices in landfill technologies are bioreactor. One is bioreactor technologies, a next generation landfill. A bioreactor landfill operates to rapidly transforms and degrade organic waste the increase in waste degradation and stabilization through liquid addition and air or enhanced microbial processes. So there are different types of bioreactor landfills. One is aerobic bioreactor. In a aerobic bioreactor landfills, as name suggests, we will provide the proper aeration system into that landfill site. So leachate is removed from the bottom and recirculated into the landfill in a controlled manner for the proper reaction to happen inside that bioreactor system. Then air injection into the waste mass using vertical or horizontal valves to enhance aerobic activities. Then in anaerobic bioreactor, there will be no no air content will be provided. In an anaerobic landfill, bioreactor landfill, moisture is added to the waste mass in the forms of recirculated leachate. But as we are not going to provide any air, okay, so the organic content present inside that landfill site will go under anaerobic digestion process, which will result in the formation of the biofuel gases like CH4 or CO2. So biodegradation occurs in the absence of oxygen and produces landfill gas. Landfill gas, primarily methane, can be captured to minimize greenhouse gas emission and can be used for energy projects. Then third one is hybrid, which is a mixture of aerobic or anaerobic process. The hybrid bioreactor landfill accelerate waste degradation by employing a sequential aerobic anaerobic treatment to rapidly degrade organics in the upper sections of the landfill and collect gases from the lower section of the landfill. Operation as a hybrid result in the earlier onset of methanogenesis compared to aerobic landfills. Then by incorporating nitrogen cycle control, the ammonia can be partially treated to create a nitrated leachate, which is leachate treated to convert ammonia to nitrate. The nitrated leachate serves as an electron donor, much the same way oxygen or air would in an aerobic landfill. So unique features of these bioreactor landfills are at a minimum leachate is injected into the bioreactor to stimulate the natural biodegradation process. Bioreactors often need other liquids such as stormwater, wastewater, and wastewater treatment plant sludge to supplement leachate. Then moisture content is the single most important factor that promotes the accelerated decomposition, approx around 35 to 65%. Optimal moisture content should be maintained during in these bioreactor landfills. The effect of bioreactor is that it produces landfill gas like methane in an anaerobic unit at an earlier stage in the landfill's life at an overall much higher rate of generation than traditional landfills. But presently in India, no bioreactor landfill is working. But in some foreign countries like USA, they are uh, they are using some bioreactor landfills for the proper decomposition of the municipal solid waste in landfill sites. So now we will
Sir,
go with yes.
sir, what is the reason that in India no bioreactor is working, sir?
If we talk about India, these bioreactors uh, will require are going to require a very high capital cost. Okay, so maybe we as of now we don't have any bioreactor technology which has been solely developed by Indian scientists. Okay, so in that case we have to buy the technology from the foreign countries and we have to rely on them for the operations of these bio reactors. Okay, and in the second thing is that in India we use very minimal parts of these minimal amount of fuel which is created with the help of these uh, landfill sites or with the help of the composting or anaerobic digestion processes. So we use very minimal amount of fuel. Okay, on bigger scale, we are majorly depend. If we talk about the energy used on the bigger scales in like thermal power plants, they use around 10 to 20% of the energy created with the help of these municipal solid waste, but 80% energy is still created with the help of the coal. Okay, so that is the major problem, because due to the indigenous technology in India, we cannot run these types of reactor systems in an economical manner. Okay, that is the main problem. So that's why we are not using any bioreactor landfills as of now. But there are many landfills in India. Like we have already discussed around, there are around 95 to 96 landfill sites, proper landfill sites, which are properly maintained by government or municipal communities of different cities, different metro cities. But there are still 90% of landfill sites which have no major equipment facilities, or we can say those around 90% of landfill sites has not been designed properly for the landfill of these municipal solid waste. So those types of landfill site is are still creating the health hazards and environmental pollutions. So that is a major concern in, if we talk about the municipal solid waste management policies in India. Okay.
Yes, sir.
Okay. So now we will. Uh, okay. Now we will go with some question answers based on today's lecture. Okay. Can you see the slide?
Yes, sir.
It is moving.
Yes, sir. It's moving.
Okay. Okay, so first question is selection of best ranked sites of landfill is done based on. So any answer?
Site sensitivity index.
Yes, we have to go with the site sensitivity index, which includes different factors. Okay, so before going to decide any landfill site, we have to check the distance of that landfill site from the water resources, from the pupil habitat, and it should have a proper connectivity with the roads, so that trucks can go at that landfill sites. And we have to check the soil quality also at that landfill site. So there are different factors which is combined as site sensitivity index, which is considered before deciding a landfill site for the municipal solid waste. Then second one, monitoring of landfill sites should be done for years after the site closure. So a site can work up to around 15 to 20 years at least. Then after the closure of that site, for how many years we have to monitor that site, which is known as pre-closure, post-closure monitoring.
10 to 20.
No, that was around 15 to 20 years. For at least 15 to 20 years, we have to monitor that landfill site after the post closure. Okay. Then, what are the factors that influence the leachate quality?
Ambient temperature.
Okay, ambient temperature. Anything else? There can be more than one answer also.
Precipitation,
Yes, precipitation will also influence the leachate quality, how much
ground,
amount of rain is falling, and groundwater intrusion also. So both three are influencing factors for the leachate quality. Okay, and then next question. What types of waste is suitable for sanitary landfills?
inert waste,
Huh?
inert waste,
Yes, inert waste can go for sanitary landfills. Anything else?
non-hazardous.
Yes, non-hazardous waste can go to sanitary landfills.
Sir, what is the meaning of commingled waste?
That is like mixed type of waste. Everything is mixed inside that waste, which can be defined as a residue after the different treatment processes like composting or anaerobic digestion. So that is commingled waste. So that can also go for the sanitary landfills, but we cannot go for the sanitary landfill of any type of non-biodegradable waste. Okay, because if we are going for the sanitary landfills of plastic or something like that, so what will happen? Those plastics are going to uh, in a long time period, those plastics are going to react with the leachates, which are going to generate into these landfill sites due to the precipitation of rainwater. Okay, and that will, uh, we can say, that will create some hazardous, we can say that will include some hazardous content inside that leachate material that will require some more different types of pre-treatment processes before going for the proper disposal of that leachate quantity. Okay, so in case of non-biodegradable waste, we generally for plastic waste, if we talk about plastic waste, we generally go for the recycling processes. Okay, so that the plastics can be reused again. Okay, so that type of waste cannot be used for a sanitary landfill sites. That waste has to be discarded before going for the landfilling of the municipal solid waste. Okay, then what are the problems associated with the leachate collection systems?
Clogging,
Yes, clogging will happen via some inert waste or the mineral content inside that leachate materials, which can create clogging. Then
uh, chemical reaction in pipes,
yes, chemical reaction can happen with because that leachate will contain the pH value of around 3.5 to 8.5.
Growth
growth
of
of
microorganisms in pipe.
Uh, yes, growth of microorganisms in pipe that will also happen. So one is remaining optimum flow rate of leachate in the outlet. So it is a problem or not?
Sir, it's not a problem, I guess.
It is not a problem. That has to be that is like a factors that is like a factor which is has to be maintained. Okay, that an optimum flow rate has to be maintained in the outlet system during the collection of this leachate. Okay, so that is not a problem. So these three are problem. Then next one, which of the component of leachate collection system is used to drain the liquid to the collector drain pipes?
French drains,
No.
Fine soil.
So that is because that will not be able to fine soil. If we are talking about fine soil, that is going to absorb your leachate. So how you will collect that leachate in the drain pipe? So we have talked about,
Drain.
okay. So when we were talking about the landfill side, so like that is a plot. Okay. So we have filled around 1 day of waste into that plot. Then we were providing some layer. Okay. Some fine soil layer or some compost layer or organic layer type on that system. Okay. Then again, we are going to create a solid waste layer. Then again, some solid system. Then again we are going to create a solid layer. Okay, so after reaching a height of around, we can say 3 to 4 feet at least. Okay, then we will provide a drainage layer on that system. Okay, so that drainage layer is going to connect. So the drainage pipe will be here on the lower side of the system. Okay, so what we are going to do, we cannot one sec. So we will provide some pipe here. Okay, we will provide some drainage collection system, or we can say pipe. uh, there will be pores on the pipe. So what will happen, this drainage layer will block the we can say leachate to go inside below this drainage layer. Okay, so the leachate will be connected in these drain pipes, and these pipes are finally connected with the final drainage system. So that is your drainage layer, which is a component which is used for the leachate collection system to collect the liquid into the collector drain pipes. Okay, understood?
Sir, the different types of layers, sir, that is slightly confusing. Refuse, tile drain, French drain.
So French drain, generally you French drain is this. This pipe is called as French drains. That French drain is like it will provide the, it can absorb the that liquid. It will provide, it will not collect the leachate system. Okay, that will contain some pores. Okay, that French drains, and that during those pores, your leachate will go inside to the other layer. So that cannot be used as a leachate collection system. For leachate, proper collection of leachate, you have to uh, stop that leachate at some point. Only then you will be able to collect the leachate system now.
Yes, sir, understood.
Yeah. Then seven, which of the components of the leachate collection system is used to protect against the damage?
Fine soil.
Yes. Fine soil is used as the components which is used to protect against the damage, because that fine soil is going to absorb some amount of leachate. Okay, so that will used as a protection against damage, because in soil content, if you are going with the soil content, that will contain some metallic quantities also in ppm level only, although it will be in ppm level. But what it will do, it will react with that leachate system. So your pH level will be maintained. Okay, that will help to maintain the pH level also during the leachate collection system. Okay, So then again, the minimum permeability of the drainage layer in the leachate collection system is
10 power minus 3 centimeter per second.
yes, it has to be 10 to the minus 3 centimeter per second. We have to obtain that minimum permeability in these drainage layers. Then what are the location restrictions that must be considered for a landfill site?
500 meter away from public parks.
So 500 meter from water supply.
Yes, it was 500 meter from water supply. For pond, I think it was around 200 meter or 200 meter. Then public parks, it has it has to be at around 100 to 200 meter at least. And from highways, it had to be nearby highway. Okay, so that the trucks can easily transport the municipal solid waste to the landfill sites. Okay. Then next one. What are the ways of controlling leachate in landfills?
Restrict runoff water, aerobic
Yes.
landfill technique,
Aerobic landfill technique. Yes.
use of proper liner system.
Yes. Through use of proper liner system. Use of heterogeneous waste not required because that will not control the leachate in the landfills. There is no use of either waste is heterogeneous or homogeneous that will not control the leachate into the landfills. Okay, so this is for today. So any questions you want to ask? If you have any doubts.
No, sir.
Okay, so if you don't have any doubts, so we will close today's meeting and we will
Sir,
meet
when
once
is the
again.
next,
Yeah.
when is the next class, sir?
Next Sunday.
Next, okay, sir.
Okay, thank you guys.
Thank you, sir.